Okay, so to finish up our video, how to practice graphing. So the keys here are very similar to what we just did. We're going to find the axis of symmetry by using our x equals negative b divided by 2a. And then from that, when we know what x is, we plug it in to find the vertex. We place the vertex as the middle row. So we put it on the graph, and that's our axis of symmetry. And we number up and down, down to the left, up to the right, our x values, plug it into the table. We find what the y values are and graph. So for today, I'm going to show you how to do this without using the table button on our graphing calculator. Tomorrow I'll fix that. But for today, all you got to do is plug it in and solve your formulas. So as you can see for number 5, our equation is f of x equals negative 3x squared. To find our axis of symmetry, well, there is no b value, so that makes 0. Negative, or the opposite of 0, is still 0. Divided by 2 times our a value is negative 3. 2 times negative 3 is negative 6. But really it didn't matter what negative 6 was because 0 divided by any number is still 0. So our axis of symmetry happens at x equals 0. A vertical line at the origin. Now, we know our points at the origin because when I plug in, if 0 is my x value, which is in the red box, if I plug in 0 to my function, 0 squared is 0. 0 times negative 3 is 0. So the origin is how I knew that, yes, that point right there is still going to be my vertex. Now, I knew that this right here is my vertex because I plugged it in. To find these other points, which I have one here, and I don't have any more. The reason is because I need 3 values to the left because I want a variety of points. So easy points. I don't want any fractions. I don't want any decimals. To the left of 0, I have an x value of negative 1, negative 2, negative 3. Those are easy, so I'm going to plug those into my table. And then to the right side, I want easy values, positive 1, positive 2, positive 3. 1, 2, 3. To get my f of x or my y values in the second column, I'm plugging them in each time. Negative 3 times negative 3 squared. Well, negative 3 times negative 3 in parentheses, very important, squared. Negative 3 squared is positive 9. Negative 3 times a positive 9 is negative 27. Now, you can see at negative 3, I do not have a point because negative 27 is way off the graph. So I didn't even plot that point, too small. When I plugged in negative 2, I got negative 12. Again, still off the graph, too small. I still need to find that point to check that, but it is too small. But when I plugged in negative 1 to the equation, I got negative 3. At negative 1 to the left, I went down 3. That's how I got my second point. Now I keep going down my table. I already found 0, 0. Then I found 1. When I plug in 1, 1 squared is 1, times negative 3 is negative 3. At positive 1, I'm down negative 3. They are the same. I could reflect them across that line of symmetry, the axis of symmetry, and they're the same y value. If I keep going, I plug in 2, I get negative 12. Too small. 3, or I'm sorry, yeah, still too small. 3, I get negative 27, too small, off the graph. So that's why this graph only has 3 points. Sometimes you'll have 5, sometimes you'll have 7. Our goal is to have as many points as possible to really show that curve. Now the domain and range have not changed. This graph is going forever to the left. That's negative infinity. It's going forever to the right, positive infinity. So that's all real numbers. Fun fact, all quadratic functions will be all real numbers. Every single one of them. Because they either open up, forever to the left, forever to the right, or they open down, forever to the left, forever to the right. So always, always, always all real numbers. That's nice. Now for the range, please ignore this right here. Really the range is, well, it's going forever down, so the smallest value the y's can be is negative infinity. The biggest this graph gets is at the vertex. That y value, the biggest y value in our table, for example, is at 0. So that's negative infinity, comma, 0. 0 is in brackets because the vertex is on the graph. It includes those points. And that's our graph. It only included 3 points. Now, it does change just a tiny bit more. So for number 6, again, I'm looking at the graph. My A value is 1. It's positive. I know my graph's going to open up, which you can see right there. B is negative 6. So when I plug it into my axis of symmetry, I get the opposite of negative 6. Really means positive 6 on top of my fraction. Over 2 times 1. 6 divided by 2 is 3. So my axis of symmetry occurs at x equals 3. When I plug in that x equals 3 to the equation, right here in the box you can see when I plug it in I get a y value of 2. So my vertex is at 3, 2. To find my other points, I want easy ones. Well, to the left of 3 is x value of 2, 1, 0. So that's where this, and this came from. 2, 1, 0. Then I want 3 points to the right that are easy. 4, 5, 6. When I plug those in, I just typed them on my calculator. 0 squared minus 6 times 0 plus 11. 0 minus 0 is 0 plus 11. The y value is 11. So that's how I got this one here. I plug in those x's I find. 0, 11 is off the graph. So that's why I don't have a point at 0. Too big. When I plug in 1, I get 6. So that's this point here. When I plug in 2, I get positive 3, this point here. We already plotted the vertex on that yellow line, the axis of symmetry. At 4, I get a positive 3 because it's going to mirror the other side. At 5, I get positive 6. Again, going to mirror the other side. At 6, I get 11. Too big, not on the graph. Still need to find it. I still need to find 7 points to double check myself. Make sure I'm doing it correctly. And then to have a variety of answers. Some graphs will be bigger than others. Some will show it all. The domain is always all real numbers forever to the left because of these arrows. And it's going forever to the right. So that's all real numbers. The range, sorry about that, let me get that out of the way. The range, well, the smallest y value is at y equals 2. In brackets, it does happen at that point. And this is going forever up. That's positive infinity. So the rest of the examples, 7, 8, 9, 10, we are actually going to go more in depth on tomorrow. So kind of skip number 10 for now. 7, 8, and 9 are still on the page below. So on the link below, you can get them right here if you pause the video as well. So if you pause the video, you'll see my answers for the domain, range, and the values and how the graph should look. I do recommend practicing those. Here's 9 and 10. Again, I changed the domain and range so you can actually read it. So on the range on number 10 is actually all real numbers. We'll come back and visit that tomorrow when I'm there to explain it a little more in person. The last bit I want to talk about is graphing quadratic inequalities. So these inequalities, the same idea, we find our table of values, we find our axis of symmetry, and it's always going to be in the middle row. When I know what that axis of symmetry is, I plug it in to find my vertex. Now the only thing is inequalities. I need to graph using a dashed line for less than or greater than, or a solid line for the parabola for the u. And I use the solid line for less than or equal to or greater than or equal to. Then I shade above the line or the graph for greater than or equal to, or below the line for less than or equal to. Process hasn't really changed that much, so I'm going to go through one example, maybe two. Number 1, f of x, or y, our equation, is greater than x squared plus 2x minus 2. So that means my axis of symmetry is the opposite of b, so negative 2, over 2 times positive 1. Negative 2 divided by positive 2 is negative 1. So my axis of symmetry is right here. I'll try to keep that as straight as I can. at -1. To find my vertex, which is right here, I plug in -1 to the equation. When I plug it in, -1 squared is +1, plus 2 times -1, which is really +1 minus 2. Oops, ignore that. Minus 2, and then minus 2 again. Well, that gets us 1 minus 2 is -1. -1 minus 2 is -3. So our vertex is at the point -1, -3. To find my other points, I want easy ones. -2, -3, -4. And then on the other side, 0, 1, and 2. When I plug those in, here's my values. And I graph. So at -2, I got a -2. And -3, I had 1 right there. And at -4, I had 6. On the other side, they're going to be the same. Well, 3 points over is at 6. Right here. 2 points away is at 1. 1 point away is at 0. So I just go that distance from the line. Because our symbol is greater than, we have a dashed line. Because of the symbol greater than. So that's why there's holes, there's dashed lines for our parabola or U. Because it's greater, we shade inside or above the line. Think about it like this. This graph goes forever this way, and this one goes forever this way. Above is all up in here, so in between the U, above the vertex. That's kind of the way I think about it, above the vertex, which is in the parabola. So then the outside is not shaded at all. Real quick, number 2. F of x is less than or equal to. So I'm going to have a solid line, and I'm going to have smaller is where I'm going to be shading. Our a value is -1 x squared plus 4 for b minus 1. So to find our axis of symmetry, I plug in -b, which is -4, over 2 times -1. -4 divided by -2 is +2. So our axis of symmetry is at x equals 2, right here. Since that's our axis of symmetry, I plug it into the equation at +2. I write it in the middle to make it easier for my table to make sure it's going from least to greatest. At +2, when I plug it in the equation, I get 3. So my vertex is at +2, +3. To find my other points, well, to the left would be 1 smaller, 1 smaller than that, 0, 1 smaller than that, -1. And here's the values I get when I plug those in. The other side, to get bigger, would be +3, +4, +5. And here's the values I get for that. So on the graph, here are my points. There's one. Here are my points. I try to make them red a little stand out. Because it's less than or equal to, I have a solid U. Less is smaller than the vertex. So below the vertex is in between the U. In between going down. So if this one was greater than Y, I think greater than the vertex would be up here, which is everything above the line. So that would be the difference. For the rest of these examples, you can keep pausing the video and follow through. They are also in the link below. So here is 3, 4, 5, and 6. Again, pause the video, you can copy those down, or just go to the link below this video on Canvas. But that's it, guys. If you need any help, I'll be there tomorrow and we'll kind of break it down. And I'll show you how to use a calculator to make things a little even quicker than what we did today. Have a great day.